Is that okay? I'm just using the coefficients.
1 sec. So did you multiply or did you?
I'm using the coefficients in front of NaOH and Na2SO4.
Okay. How did you?
Please ask as many questions as you need to.
Okay. To get Na2SO4, you just pulled that number from the problem, like you didn't do
Yeah.
any calculation.
No,
Okay.
if it's not written, it's a 1. There's no calculations there.
Okay.
And then the last, sorry, are you ready?
Yeah, I got it.
So we're going to put 1 mole Na2SO4 down here on the bottom, and we're going to get the molar mass of Na2SO4 on the top. So go ahead and calculate that. Let me know what you come up with.
A mole of
Na2SO4. So you're looking for the 2 times Na, which is 32, or sorry, 23. 2 times the 23. 1 S is 32, and then 4 oxygens, 4 times 16. Let me know if you need me to go through that in more detail.
Yeah, I think. Yeah, can we do that with a little bit more detail, please?
Sure. Yeah, so here's what I'm doing. I'm going to make a little table. So the table is 2 NAs, 1 S, and 4 O's. So Na is 23 grams, S is 32 grams, and O is 16 grams.
Mm-hmm.
So you just multiply, so that's 46, 32, and 64. Add those up and you get 142 grams.
Oh.
And if it's not clear where those numbers are coming from, I can pull up the periodic table and show you, but it's the molar mass in the periodic table.
Uh-huh. Yeah, I mean, I get the middle numbers. So the 2, the 1, and the 4 are just the coefficients then?
Well, it's the subscripts. So there's
Oh, the subscript. Oh,
2
okay.
NAs, 1 SO, or 1 S, and 4 O's.
Oh, sorry. Okay, yeah, I got it. Okay. Okay, cool.
Okay, so now that that's taken care of, again, you'll notice the units on the top left match the units on the bottom right. Okay, so do you see how they're the same again? These top left. So what that means is everything it cancels. They all cancel. But you've got to be able to do this calculation. You got to take 2 times 1 over 40 times 1 over 2 times 142 over 1. Do you have any questions about how to enter that into a calculator?
I'm just entering in the entire equation or just a part of it?
All of it.
Okay.
Like in some ways you're multiplying the top numbers. It's really 200 times 1 times 1 times 142 divided by the result of 40 times 2 times 1.
I got 355. Matthew, I don't think I can hear you right now.
Sorry about that.
Oh, okay.
That was bad. Sorry. So 355 grams of Na2SO4.
Hmm.
Is that okay?
That's what I got. Yeah.
Okay. Ready to move on to 13, I guess.
Hmm.
So all of this is leading up to limiting reactants, and you probably haven't seen them yet, but that's where you're going. They give you another equation. I think it's safe to assume it's balanced. So we don't have to do any work. We're good there.
Yeah.
So how many grams of lithium nitrate? Where is lithium nitrate in this? Which one is it?
LiNO3.
Good. Okay. Will be needed to make 250 grams of lithium sulfate. So that's this one on the right here. Assuming that you have an adequate amount of lead for sulfate to do the reaction. Okay. So you always start with the given quantity, 250 grams Li2SO4.
Times times lead.
So we've got to get the molar mass of this and see
Okay.
if you can calculate that on your own. I will also calculate it and we can compare results.
Times. I got 110.
I got 103. So let's just go through it real quick. There's two. No, it is 110. I'm sorry. I didn't have my two. It is 110. Yeah, 110 grams Li2SO4.
Why
And
does
that's
that go on the bottom?
so you always match the one that's on the top left.
Oh, right. That, yeah.
Okay. So again, just to, you asked, you put the one that's top left in the bottom right. Like that.
Oh,
So
okay.
now, but it may not be 1 mole, but the units are the same. So this is the mole conversion. This is where you're using the coefficients in the equation. So there's 2 moles there, 4 moles there. You're using the coefficients. So 2 moles Li2SO4 for 4 mole LiNO3.
Sorry, just give me a second. Okay. And because we took that right from the equation,
Yes.
are the coefficients always gonna mean uh moles or
Yes. Yes.
okay,
Yes. Good question.
got it. Cool.
So on the bottom right here is mole LiNO3. We want grams. grams LiNO3. So this is where you're doing the molar mass.
And to get the how did we go from 4 mole LiNO3 to 1 mole LiNO3?
So that on the right here, okay, so in red, let me tell you what red is. Red is the mole conversion in the equation. The other ones here are the molar masses.
Mm-hmm.
So the molar masses always have 1 gram. So you've got to find the molar mass of LiNO3.
Sorry, Matthew. Just walk me through it one more time.
Yeah, please, yeah, keep asking. So
Okay.
it's the overarching principle here is you can't work in grams. Grams are useless. Okay, so you always convert grams to moles. That's what we did in this blue. Okay.
Mm-hmm.
So you get the moles. Like if you were to actually do this calculation, you would get the moles of this. Okay, and
Yeah.
moles are what you actually can convert between. And that's what the mole conversion equation is. It's like, all right, I got to go from, in this case, the products back to the reactants using the coefficients of the equation. Once you're back here on the reactant side, you want to convert from mole back to grams because the problem's asking how many grams you need.
Oh, so we're going from
You're going from grams of this Li2SO4 to
and
moles.
that's the first equation we did the
That's this one, yeah.
okay. And so this equation gave us the what number? Or did it?
Which
I'm
one? The
just,
blue, the red, which one?
sorry, the first blue.
Yes.
2 Li SO4 is the product of that first equation.
Well, okay, and these are the reactants, and then the products are on the right. That's just how they express this in chemistry.
Mm-hmm.
So you can't work directly in grams. That's why you always convert grams to moles.
Mm-hmm. Okay. Oh, okay. Yeah, that makes sense. So
And then to go, so this red is really like going from the products to the reactants, or the reactants to the products, depending on the equation.
mm-hmm.
And
Okay.
then this last blue is like, okay, we know moles.
We're
We know
doing
mole,
grams now.
so you got to convert it back to grams, which is why you need the molar mass.
Okay.
So let me know what you come up with for the molar mass of LiNO3.
I got 69.
Good. Yeah, 69 grams. Okay. So now let's just grab the calculator, multiply.
Oh yeah. 69, 276 divided by I got 1.25.
Okay, so did you get this 250 here?
Oh no, I totally missed that. 250.
Should be about 314 grams of LiNO3.
Oh, I got 2.39 this time.
Okay, so I'm guessing there's an issue with how you're putting in your calculator.
Yeah.
The way to do it is to multiply the top numbers.
hmm
And then when you divide, you put parentheses. So it's 110 times
Oh,
2 times
I
1.
see what I did. Yeah, I added 250 plus times. Okay, yeah. There we go. So 314 grams. Cool.
Do you have it all down?
Yeah.
Okay. All right, fermentation is the complex chemical process of making wine by converting glucose into ethanol and carbon dioxide. So sometimes, I don't even know what this stuff is, but by reading the language, I can detect, okay,
Mhm.
glucose is what they started with, and ethanol, that's some sort of ethanol, and that's the carbon dioxide there on the right. It looks balanced because they've already put coefficients in front. On a tester quiz, you may be asked to do that. Calculate the mass of ethanol produced if 500 grams of glucose reacts completely. Okay, so you're starting with 500 grams of the C6H12O6. So whatever you have in the top left goes into the bottom, the units. So grams of C6H12O6.
hmm And then on the top
So you got to
shows
find
the
the,
molar mass.
well, it's 1 mole of this.
Oh,
You've got to figure out how many grams that
and
is.
that's always going to be 1 mole
Yes.
right there. Okay.
C6H12O6. Okay. Yeah, I've got that.
Uh, 180.
Yes. Okay. So this is now we have the moles of glucose, and we want to figure out the mass of ethanol, but you can't do that directly. You have to go to moles of ethanol. So that's where you do your mole conversion up here at the top. Um, so moles C6H12O6 from the top left, moles C2H5OH, and this is where you write the coefficients from the equation.
Okay, and now we can convert back to grams.
Yeah, so 1 mole of what's on top, C2H5OH.
That's also going to be 1 always.
Yes.
Okay. Seasoning. Uh, 46.
Yes. Now you have to do the calculation.
Mm-hmm.
Again, just be careful. You're multiplying everything on the top divided by, and on the bottom you have to use parentheses or your calculator won't know what to do.
I got 255.
I'm
Or
going to round up to
256.
256 grams of C2H5OH.
Okay.
Right. Be nice to know what, actually see this happen in real, something real in front of you, but
Mm-hmm.
it's not that simple.
That'd be
All right.
cool.
Yeah. All right. So we got a new problem here. What mass of H2O is formed when H2 reacts with 384 grams of O2? Now, one of the things that's different about this problem is they don't tell you that like you have enough of the other.
Mm-hmm.
Did you guys have not talked about limiting reactants yet for products?
No, we haven't. And
Okay.
actually, on 16, she told us to cross out part of the problem
Okay. All
because
right.
it was about limiting reactions.
All right. Yeah. Okay. So again, just start with the given quantity, 384 grams O2. And we got to find the molar mass of O2.
It's 32.
Yeah. And then you're going to do your conversion from the reactants to the products. One mole O2 is 2 moles H2O.
So, oh yeah, never mind. So 33 and then
What's the molar mass of H2O?
33 grams.
So you get two H's and one O.
Oh,
I think you doubled your O.
18
Yeah.
18
There it is.
grams.
Right. Let me know when you come up with your final calculation.
Mm-hmm. Uh, 43 gram or
I
43 grams.
I got something different. Check your calculation one more time.
Okay. Oh. $432
Yes.
grams.
Grams of H2O.
Got it.
Do you enjoy chemistry? Have you
Yeah, I like science. This is just kind of hard.
have you guys done any experiments, lab stuff?
Yeah, we did. We got to use the Bunsen burners to make sugar kind of heat up, and it was cool.
Okay.
So
Right. So,
we know 35, right? 35 grams. So that's our starting number.
yep. And then grams C6H10. And then mole C6H10.
So 1 mole C6H10,
Yeah.
and then
How many grams is that?
$82 grams.
Yeah. And then
And
you go
then
mole C6H10. Notice I'm always writing the bottom one first. I think that also helps.
mhm.
And we're going to a CO2 this time.
How do we know whether we're going to CO2 or H2O?
It has to tell you.
Oh,
I mean,
okay.
it could ask for both, but in your class,
Yeah.
I'm sure it'll tell you.
Okay.
So that's 2 to 12.
Two, 12. We just plug those in. And then now 1 mole of CO2 under
35. Do you have a result here?
Yeah. Oh, whoops. Sorry, I multiplied them. Divided by. I got 112
Yes.
or 113
Yeah.
grams of CO2. Nice.
All right. Well, hopefully that's a little clearer.
Yeah.
It does get more difficult from here with limiting reactants, but hopefully you'll get enough time to be
Hmm.
able to work through that, you know.
Yeah, definitely. This definitely helps.
All right, so we got some time left here. Is there something else you'd like to work on today?
Uh, no, I don't have anything else. Could we do one more like practice problem maybe?
Of
I
of
don't know if
of
you can find anything or.
of these type?
Hmm.
Sure. Yeah, let me find this might be useful, this picture. I don't know, let me snip it in here. This is kind of what you were asking me about in the beginning, which is this map of like,
Oh yeah.
and I don't, maybe you've seen this in class, but if
Hmm.
you're given grams, use the molar mass to convert it to moles. Use the balanced chemical equation mole ratio to convert it to moles, and then the molar mass to go backwards.
Yeah.
Well, the first worksheet I found is almost a copy of the last. It's exactly this problem. So you can tell your teachers don't look very hard for questions. Don't tell them that though.
It's cool if you can't. I mean, I
No,
got enough. I got a good understanding of it, so.
yeah, the is this exactly the same? Sorry, I just want to look
Yeah, all
here.
good.
I mean, I can find. I just need another minute to find one if you want.
Yeah,
Just
for
have to
sure.
go,
Take your time.
just have to go to the next website here. All right, this one is unbalanced, so we can quickly balance it. Okay, so to balance this equation, I'm gonna put a 2 here. That gets the O3 balanced. And then 2 O's, I've got 4 there. So if I put 2 there, that's gonna change that. Of course, they give you a really difficult one here. So that's not gonna work. So we've got, let's go 3. That gets you 6. 3. Is that right? That gets you 6. 3 C's, 3 C's, 6 O's, 3 O's and 3 O's, and then 2 there. Okay, so now it's balanced. Okay, so this is like this should be just say assume that's grams. or actually, let's make it one. It's 150 grams. So
Okay. Calculate the number of grams of CO they can react with 150 grams of iron. So 150 grams. One mole. 3. So 6. One 60 grams of that. And then 1. We're using C. When it says grams of CO, does that mean like CO2 or?
no, it's
Oh,
this one here. I mean, we can make it CO2 if you want, but
I don't know.
it we're just doing another. I mean,
Yeah, I just didn't see it. CO. Grams of CO. And then 150. And I got 78 or 79 grams of CO.
does your setup look match mine? Because I just getting to the
Yeah, it
calculation.
does.
Okay. You said 78, 79.
79, yeah.
Yeah.
Rounded.
Good. Good. Yeah, I mean that's it. I mean there's not
Cool.
much more to it. I mean the
Yeah.
balancing could be an issue, but that is it. So I guess we can stop here for today.
Yep.